All right, let's get right into it. We are tackling one of the biggest, most mind-bending questions you can possibly ask. Is time real? I mean, it feels like the most real thing there is, right? But what if I told you that physics has a completely different story to tell? And trust me, it gets weird. We all have this feeling, don't we? That time is this massive cosmic river. It's just carrying us along from the past through this moment right now and off into the future. It feels constant, it feels unstoppable. But here's the kicker. What if that feeling is totally wrong? What if that flow we feel is just a mental shortcut? A story our brain tells itself to make sense of a reality that's actually much, much stranger and more static than we can imagine. And that's the big puzzle we're going to piece together today, our own human perception versus what physics says might actually be true.
So to really get a grip on this, let's start with the idea of time that we all basically grew up with. This is the classical view, the one that ruled science for hundreds of years. This is time according to the one and only Sir Isaac Newton. You see, for Newton, time was super simple. It was absolute. Just imagine a giant, invisible clock for the entire universe, ticking away at the exact same pace for everybody. A second for you is a second for me is a second for an alien on a distant planet. It's clean, it makes sense, and honestly, it feels right. And then Albert Einstein shows up. And he doesn't just adjust that big universal clock. Oh no, he takes a sledgehammer to it and smashes it into a million pieces. His theories of relativity didn't just change our ideas about time, they completely blew them up.
And just look at this comparison. It's night and day. Newton's time is this rigid, universal thing, completely separate from space. But Einstein comes along and says, nope, time is relative, it's personal, and it's not separate from space at all. They're woven together into this four-dimensional fabric he called spacetime. So instead of a constant flow, time becomes this flexible, stretchy thing that can be warped by gravity and speed. And that leads to one of the wildest but proven ideas in all of physics, time dilation. Get this, the faster you move through space, or the more intense the gravity you're in, the slower time actually passes for you compared to someone else. And this isn't science fiction, it's a real, measurable effect. Your GPS satellites have to account for it every single day just to work properly. The best way to wrap your head around this is the famous twin paradox. So imagine you have two identical twins. One stays here on Earth, while the other hops in a super fast rocket and zips around the galaxy close to the speed of light. When the astronaut twin comes back, they will be physically younger than the twin who stayed home. They've lived through less time. That's it. The universal clock is officially broken. Okay, so just when you think reality can't possibly get any stranger, we're going to zoom all the way in, down to the quantum level, the world of tiny subatomic particles. And down here, the rules of time don't just bend, they pretty much fall apart. You know, in the quantum world, time is a total ghost. You can measure a particle's position or its momentum, but there isn't really a way to measure its time. It's just sort of there in the background of the math, but it behaves like nothing else. And this disconnect, they call it the problem of time, is one of the biggest roadblocks preventing physicists from coming up with one single theory of everything. All right, let's zoom back out a bit from all that quantum weirdness and ask a slightly different but just as deep question. If the basic laws of physics don't really care if time runs forward or backward, then why do we only experience it in one direction? Why do we remember yesterday but have no memory of tomorrow? The best answer we have comes down to this one word, entropy. Now, entropy is basically just a fancy scientific term for disorder or randomness. And one of the most fundamental rules of the universe, the second law of thermodynamics, says that in any closed system, like our universe, total disorder can only go one way, up. Things always get messier over time, never neater. A really simple way to think about it is with a deck of cards. Imagine starting with a brand new deck, perfectly ordered. That's a low entropy state. Now throw them up in the air. What are the odds they land back in perfect order? Pretty much zero, right? They're going to be in a random, messy, high-entropy state. Our universe seems to have started in a very ordered state, and its constant, unstoppable journey toward more and more disorder is what we feel as the forward arrow of time. Okay, so all of this leads us to one of the most radical ideas in modern physics. What if time isn't fundamental at all? What if it's not a basic building block of reality, but something else? Something that just emerges? So the thinking here is that at the deepest, most fundamental layer of reality, there might not be any past, present, or future. No time at all. Instead, what we call time emerges from the interactions of countless more basic bits of reality. It's kind of like wetness. A single molecule of H2O isn't wet, but get a trillion of them together, and you get the property we call wetness. Maybe time is like that. And this whole debate isn't just for physicists. Philosophers have been arguing about it for centuries. You've got the presentists who say that only this very moment, the now, is real. The past is gone, the future hasn't happened. But then you have the eternalists whose view fits a bit better with Einstein. They think the past, present, and future are all equally real, existing all at once in what they call a block universe. Our consciousness just happens to be experiencing this one slice of it right now. So, what's the bottom line here? Well, from a practical engineering point of view, time is something we can measure with incredible precision. But does that make it fundamental? Not necessarily. It might just be an incredibly useful construct, a powerful tool our minds and our math use to build a model of the universe that works. Which, of course, leaves us with one last giant hanging question. If our most basic experience of reality, the steady flow of time, is actually an illusion or an emergent property of something deeper and timeless, then what does that say about everything else we think is real? What's really going on at the bottom of it all? Now, that is a question worth spending a little time thinking about. Thanks for diving in with me.